In this session, we will be seeing about three-phase inverters. Inverter is a device which converts DC power to AC power at required voltage and frequency. So, we can draw the three-phase inverter circuit diagram. It consists of a DC supply and the DC supply is indicated as Vs. Here there are 6 semiconductor switches are there for three-phase inverter. Here the switch considered is thyristor. And at the input, to provide a constant DC supply, a capacitor is connected. Parallel to that of thyristor switches, a diode is connected anti-parallel. This is phase A. Similarly, we need to draw phase B and phase C. Phase B phase B switches are shown here. Phase B switches are shown here and the anti-parallel diodes are connected. Similarly, phase C. A three-phase load is connected at the output side. Three-phase load. This is A phase, B phase, C phase. VAB, VBC and VCA are the line-to-line voltages. A phase, here also we are indicating A, B and C phases. Numbering of the elements is same as that of in rectifier three-phase circuits, that is 1, 3, 5 belongs to the upper group and 4, 6, 2 belongs to lower group. Similarly, D1, D3, D5 belongs to upper group of diodes and 4, 6, 2 indicates lower group of diodes. We are discussing about two pattern of gate pulses are there for this three-phase inverter, that is 120 degree and 180 degree conduction mode of operation. Here we are discussing about 180 degree conduction mode of inverter. So here three-phase 180 degree VSI is going to be discussed. Three things need to be in mind for drawing the switching pattern as well as line to line voltage and line to neutral voltage. One is here each thyristor conducts for 180 degree. This is 180 degree mode of operation. So each thyristor conducts for 180 degree. And gate pulses are given at an intervals of 60 degree, which means first if gate pulse is given to T1, then after 60 degree T2 will be turned on. From turning on of T2, after 60 degree T3 will be turned on. Like that switching happens. So gate pulses are applied at 60 degree intervals. Gate pulses given at 60 degree intervals. Here complete cycle will be a 360 degree. Steps 360 degree is the complete cycle, which means each step will be 60 degree. So each step of voltages will be at an interval of 60 degree. Total 6 steps will be there. So full cycle is equal to 360 degree. Now we can draw the switching pattern of the 3-phase inverter with 180 degree conduction mode. Indicating it in a graph paper. In leg A, this is first leg. First element is T1. So T1 will be operated for 180 degree. Each element operates for 180 degree. So first element is T1. Here in the graph, each block is measured as 60 degree. So if each block is 60 degree, T1 is operating for 180 degree. So 1, 2, 3 blocks, 180 degree. T1 operates for 180 degree. After T1, T4 will be switched on. And T4 is operating for a 180 degree duration. Next again T1. In the first row, we are indicating switching pattern of first leg, that is T1 and T4. In the second row, we are indicating elements of second leg, that is T3 and T6. So after T1 is switched on at 0. So after T1, T2 will be switched on at 60 degree. So here T2 will be switched on after T1, after 60 degree of interval, T2 will be switched on. After that 60 degree, T3 will be switched on. So we indicated T3. Each element conducts for 180 degree. First T1 is switched on. After 60 degree, T2 is switched on. Again after 60 degree, T3 will be switched on. Again after 60 degree, T4. Again after 60 degree, T5. Again after 60 degree, T6. Like that switching pattern will go. So here first T1. After 60 degree, T2 need to be turned on. But we are drawing it in third row. Now we are drawing the second row, which indicates the second leg. So after again 60 degree, T3 will be switched on. T3 conducts for 180 degree. Then after that, T6 will be turned on. T6 operates for 180 degree. Then next again T3. So before T3, T6 was conducting. In the next row, we will be indicating the switching pattern of third leg. That is, third leg consists of T5 and T2. So T2 is fired after 60 degree. So here T2 is fired. T2 conducts for 180 degree. After that T5 is conducting. Again T2. So before T2, T5 was conducting. This is the switching pattern of three-phase inverter at 180 degree. We need to indicate the angle, that is here 0, 60, 120, 180, 240, 300, 360. Again repeating 60, 120, 180, 240, 300, 360. Each step is indicated as step numbers 1, 2, third step, fourth step, fifth step, sixth step, like that. Now we need to draw the line to neutral voltages. For that, first we need to know what are the elements in conduction at step 1. Step 1 is from 0 to 60 degrees. So elements of conduction is 1, 6 and 5. If we are writing it in order, then it will be 5, 6, 1. So first we need to draw a circuit where 5, 6, 1 is made on, and then draw the load equivalent circuit. From load equivalent circuit we will be able to find the value of line to neutral voltage. For that, first we are going to do step 1. Step 1 is from 0 to 60 degree. And during this period, the switches which are operating is 5, 6, 1. So 5, 6, 1 closed. To draw the circuit, first we need to indicate the switches. Plus minus, input voltage is indicated as Vs. And switches are 1, 3, 5, 4, 6, 2. A phase, B phase, C phase. Indicate the three-phase load. A. And now the switches closed are 5, 6, 1. So 5, switch number 5 is closed, 6 is closed and 1 is closed. Now 4, 3, 2. are open. Draw the equivalent circuit of load here. That is, positive of the supply voltage is connected to directly phase A and phase C. Negative of the supply is directly connected to phase B. So positive is connected to phase A and phase C. Negative is connected to B. A, C, this is neutral or common point O, plus minus. Here Z is the impedance at each phase. So here the impedances are connected in parallel, so equivalent value will be Z by 2. Here the value is Z. So what is the current flowing here in the circuit? If the load is connected in this manner, what will be the total current flowing? That we need to find. I is equal to Vs divided by R. Here R is the total impedance, Z plus Z by 2, which is equal to 2 by 3 Vs by Z. Now we need to find what is the voltage across AO, VAO. VAO is the line to neutral voltage. Okay. Line to neutral voltage. Neutral voltage VAO is equal to VCO, which is equal to I1 into Z by 2. What is I1? I1 we got it as 2 by 3 Vs by Z into Z by 2. Z cancelled, 2 and 2 cancelled. We obtained the voltage as Vs by 3. Similarly, VOB is equal to, here what is VOB? VOB is current into impedance, I1 into Z, which is equal to I1 we know like 2 by 3 Vs by Z into Z. Z cancelled, we obtained it as 2 by 3 Vs. If VOB equal to 2 by 3 Vs, then VBO we can write it as minus 2 by 3 Vs. We need to mark these line voltages obtained in the graph. For that, first we need to draw x-axis for the line voltages. First we are drawing 3 line to neutral voltages, which is the phase voltages, and that is VAO. First one is VAO. VAO we obtained as, the voltage we obtained as VAO is Vs by 3. So we need to indicate here. Here a block is considered and the half of this block is Vs by 2. Next is, with another color we can indicate VBO. VBO we obtained as minus 2 Vs by 3. So minus 2 Vs by 3 is indicated here. This is 2 Vs by 3. Here it is Vs by 3. With another color, we can draw VCO. VCO is the another line to neutral voltage, and VCO is obtained as, we obtained VCO as Vs by 3. So Vs by 3 is indicated here. So we drawn the voltage levels for step 1. Similarly, we need to find the voltage levels for step 2. To find step 2, we need to check the conduction elements. That is, here for step 2, 2, 6, 1 are the elements in conduction. In order, we can say it like 6, 1 and 2 are the elements in conduction. So from 60 degree to 120 degree, these are the elements in conduction. We need to find the voltage levels. Then only we can draw it. So for step 2, that is from 60 degree to 120 degree. The switches closed are 6, 1 and 2. Draw the circuit from here, from the main circuit. Draw the circuits with the switches as a vacant space. Then draw the 3-phase load. A phase, so this is A, B and C. This is neutral. Impedance Z. 1, 3, 5, 4, 6, 2. The switch is closed as 6, 1 and 2. The input voltage is indicated as Vs plus minus. So here positive is connected to A phase, negative is connected to B phase and C phase. Accordingly, draw the circuit. Positive is connected to A phase. B and C is connected to negative. Here Z by 2 is the impedance. Now we need to find the current through the network. I1 is equal to Vs divided by Z plus Z by 2, which is equal to 2 by 3 Vs by Z. Then we need to find the line to neutral voltage, that is VAO. VAO is equal to I1 into Z, which is equal to 2 by 3 Vs by Z into Z, which is equal to 2 by 3 Vs. Similarly, we need to find VOB and VOC. Both are equal, which is equal to I1 into Z, which is equal to Z by 2, which is equal to 2 by 3 Vs by Z into Z by 2. Finally, we obtain it as Vs by 3. So VBO is equal to VCO is equal to minus Vs by 3. We obtained all line to neutral voltages. We can mark it in the graph. So VAO, we obtain it as 2 by 3 Vs. VBO is equal to VBO equal to VCO equal to minus Vs by 3. Minus Vs by 3. And VCO is equal to minus Vs by 3. Now next is step 3. For step 3, the elements in conductions are 1, 2 and 3. So next is step 3. 120 to 180 degree. 1, 2, 3 closed. Draw the circuit, leaving space for switches. One, 3, 5, 4, 6, 2. Load is 3-phase load. A, B, C. This is the neutral point. So 1, 2, 3 closed. 1, 2, 3. The rest switches are open. So positive is connected to phase A and phase B. Negative is connected to phase C. So drawing the equivalent circuit of load. Z by 2, here Z. We need to find the value of current. Current I1 is equal to Vs divided by Z plus Z by 2, which is equal to 2 Vs divided by 3 Z. VAO is equal to I1 into Z by 2 is equal to I1 is 2 by 3 Vs by Z into Z by 2. We will obtain it as Vs by 3, which is equivalent to VAO is equivalent to VBO. This is equal to VBO. Next we need to find VCO. First we need to find VOC, which is equal to I1 into Z, which is equal to 2 by 3 Vs by Z into Z, which is equal to 2 by 3 Vs. So VOC is equal to VCO is equal to minus VCO. So which is equal to minus 2 by 3 Vs. We can draw it in this graph where VAO we obtain it as VAO and VBO we obtained as Vs by 3. So third step, Vs by 3, VBO Vs by 3. Now VCO is minus 2 Vs by 3. Now next is step 4. Step 4, the elements of conductions are 2, 3, 4. 2, 3, 4 are the elements of conduction in step 4. So step 4 is from 180 degree to 240 degree. 2, 3, 4. Phase A, phase B, phase C. Here switches closed are 2, 3 and 4. The rest are open. An equivalent circuit we can draw it like positive is connected to B, negative is connected to A and C. But here the impedance is Z by 2 and here is Z. We need to find the value of current I1. So current I1 is equal to Vs divided by Z plus Z by 2, which is equal to 2 by 3 Vs by Z. How to find VBO? VBO is equal to I1 into Z, which is equal to 2 by 3 Vs by Z into Z, which is equal to 2 by 3 Vs. Next, VOA is equal to VOC, which is equal to I1 into Z by 2, which is equal to 2 by 3 Vs by Z into Z by 2, which is equal to Vs by 3. VAO is equal to VCO is equal to minus Vs by 3. We can indicate these values in our graph. So VBO is 2 by 3 Vs. Fourth step is 2 by 3 Vs. And VCO is minus Vs by 3. And VAO is again minus Vs by 3. We obtained 4 steps. Now we can continue the pattern. If there is any doubt, you can again calculate in the same way. These are the line to neutral voltage or phase voltage. We are obtaining 6 steps. At 360 degree, 6 different voltage levels. That is, first we obtained plus Vs by 3, then 2 Vs by 3, then again Vs by 3, then minus Vs by 3, minus 2 Vs by 3, again Vs by 3 and 0. 6 steps are there in a cycle. Okay. Next is we need to draw the line to line voltages. Line to line voltages, what are the line to line voltages we indicated in the diagram? VAB, VBC and VCA. These are the line to line voltages. To find the line to line voltages, first we need to know the equation. That is what is the value of VAB? So for the first step, what is the value of VAB? We need to first draw VAB. VAB voltage we need to draw here. For that, the VAB voltage can be written as, from the diagram, this is the first step voltages we obtained, that is line to neutral voltages we obtained. This is the equivalent load circuit diagram. What is the value of VAB? Line to line voltage VAB. So VAB is the sum of VAO voltage plus VOB voltage. VAO plus VOB. VAB equal to this is for step 1. We solved the equivalent load diagram of step 1. In that, VAO voltage, AB voltage is equal to VAO plus VOB. That we wrote here. Then from this, we can write it as VAO minus VBO. What is VAO now? In the first step, in step 1, VAO is equal to Vs by 3. Then what is VBO? In the first step, it is minus 2 Vs by 3. So what is VAB? VAB is equal to VAO minus VBO, which is equal to VS by 3 minus 2 VS by 3. So plus 2 VS by 3, which is equal to VS. So VAB value equal to VS. So mark here VAB, let this be VS. We considered a single block as VS. So first step voltage for VAB is obtained. Similarly, we can obtain the next voltage. That is, next is VBC. In the diagram, next is what is the next line to line voltage? It is VBC. So we can draw here VBC. Next, we need to find the value of VBC. To find VBC, we need to take that circuit, that load circuit. So VBC voltage we need to find. To find VBC, we need to know what is the voltage of VBO. So VBO plus VOC will give you the voltage VBC. So VBC is equal to VBO plus VOC, or we can write it as VBO minus VCO. Then substitute the value for VBO and VCO from the diagram. VBO, first step, VBO, it is minus 2 Vs by 3. So minus 2 Vs by 3 minus VCO. CO is Vs by 3. So minus Vs by 3, which is equal to minus 3 Vs by 3, which is equal to minus Vs. So we need to draw here minus Vs. Next, we need to find the VCA voltage. For VCA voltage, from the diagram, VCA voltage is equal to VCO plus VOA. VCO plus VOA. This can be written as VCO minus VAO. From the diagram or from the calculations, we can able to write the value of VCO and VAO. From the calculations, we got it as VCO is equal to Vs by 3. So it is equal to Vs by 3, and VAO we obtained as again Vs by 3. So minus Vs by 3. So VCA value is equal to 0. So we need to draw here in the graph VCA is equal to 0. So we drawn the step voltage, step 1 voltage of line to line voltages. Similarly, we need to do it for step 2, step 3, etc. So again, next one, step 2. For step 2, the value of VAB voltage. VAB voltage is equal to we need to first take the circuit diagram of step 2 voltage. Step 2 circuit diagram. In this, VAB is equal to VAO plus VOB. This can be written as VAO minus VBO, which is equal to VAO. From the graph or from the calculations, we obtain the value of VAO. VAO is equal to 2 Vs by 3. And what is VBO? VBO is equal to, second step is minus Vs by 3. So plus Vs by 3, which is equal to Vs. So VAB we obtained as Vs. Mark here Vs for the second step. And for the second step, VBC voltage. Here VBC voltage step. For the second step, VBC is equal to VBO minus VCO. That we know. We obtained it before. So what is VBO? VBO voltage for the second step is minus Vs by 3. VBO is minus Vs by 3. And what is VCO? VCO is also minus Vs by 3. Minus minus plus Vs by 3. So we obtain it as 0. VBC is 0. So we marked here 0 voltage. Then VCA. VCA is equal to VCO minus VAO. What is VCO? VCO voltage. VCO voltage is minus Vs by 3. And what is VAO? From the calculation, it is 2 by 3 Vs, which is equal to minus Vs. VCA equal to minus Vs. So VCA, we need to draw the step minus Vs. So we obtained the second step of voltages for 3 line to line voltages. Okay. Then next is third step. For third step, VAB. Same equation, VAO plus VOB, which is equal to VAO. For the third step, we need to take either from the diagram or from the calculation sheet. We will be getting the value of VAO, VOC as well as VBO. So from the calculations, VAO is equal to Vs by 3 and VBO is equal to minus Vs by 3, which is equal to 0. VAB voltage is equal to 0. So mark here VAB voltage, that is 0. Now from direct inspection, we can draw the rest of the voltage levels, that is VBC. VBC is equal to VBO minus VCO. VBO here is Vs by 3. Vs by 3 minus 2 Vs by 3, which is equal to Vs. So it is plus Vs. Next is VCA. VCA is VCO minus VAO, right? So here is VCO. VCO is minus 2 Vs by 3 minus Vs by 3. So it will be minus Vs itself. So minus Vs. Now next step, fourth step. Here directly we can write VAB is equal to VAO minus VBO. That is VAO is minus Vs by 3. Minus Vs by 3 minus 2 Vs by 3, which is equal to minus Vs. Here next line to line voltage, fourth step, VBC. VBC is equal to VBO minus VCO. Where is VBO? Here is VBO. VBO is 2Vs by 3. 2Vs by 3 minus Vs by 3. So 2Vs by 3 plus Vs by 3 is equal to Vs. Next VCA. Fourth step, VCA is equal to VCO minus VAO. What is VCO? VCO is minus Vs by 3 minus VAO minus of minus, which is plus Vs by 3. We will obtain it as 0. Now 4 steps we obtained, and then after this just continue the same as previous one and complete the waveform. Thus, we can mark the corresponding voltages. Here we know that here the voltage we obtained is Vs, and here it is minus Vs. Minus Vs. And here for line to neutral voltage we obtained this voltage as 2 Vs by 3. And this is Vs by 3. Minus Vs by 3. Minus Vs by 3. Minus 2 Vs by 3. And we can mark here 180 degree half cycle is completed. This is the pi. And here 360 degree, this point 2 pi. Here 3 pi, 4 pi. And here also we can indicate like VAB equal to VAO minus VBO. Similarly, VBC is equal to VBO minus VCO. VCA is equal to VCO minus VAO.